Alright, this is the CS 159 2020 Fall Exam 1, and there are 25 questions on this exam, so let's get started. So, first question, it is asking us which of the following is the output generated by this program that we see here on the right. So, first order of business is we enter our main function. As every program, this is where you start the execution of the code. So, what I like to do for this is to keep track of my variables. So I'll put an x and I'll put a y for these two x and y variables that we see, and I'll keep track of the values as we go through this code. So they start out as 12 and 5. So then we get into this next, our execution continues onto this next line where this trace fx function is. So the first thing we see here is this x plus plus. So this plus plus means that we'll increment it after this line of code is executed. So that means the value being passed through here is just going to be 12. And then on the right here, we see plus plus y plus 1. The plus plus coming before the y means that we'll increment it before the execution occurs. So that means this y is going to increase to 6. We'll put a 6 right here, add 1 to it, and this will give us 7, of course. So now we have to enter this trace fx function, and so this 12 will get put into this first parameter, which is x, and the 7 will get put into this first parameter, which is y. Note that the naming of these parameters, even though they are the same, does not matter whatsoever. It's just the order of the numbers that matters when passing it to these functions. So we know that this x will be a 12 and this y will be a 7. So we can also keep track of separate variables down here. So we'll keep track of our 12 and we'll keep track of our 7, as these variables are separate from the ones in main because it's in a different function which has different scope, and there's no pass by address occurring here. So then we also see that we have this temp variable within this trace fx function that we want to keep track of. So then we come down into the calculation line here and we see kind of the same thing we saw in the main function. So we have this plus plus x, which as we know means we increment it before. So this x becomes a 13, and then so we have a 13 right here, and this y plus plus means that it occurs after. So this y will just be a 7. So we see here that 13 divided by 7, and although that may seem like it's going to be a decimal number, it's important to note that both of these numbers are integers, and when you divide two integers in C, this results in integer division and results in the truncating of the decimal point. So since 13 divided by 7 is 1 with remainder of 6, this means that the result of this calculation will merely be 1. But note that we have a double here, so this type gets increased to a double, but this occurs after the calculation occurs, so this means that this is merely just a 1.0. So temp is 1.0. So then we go down into this print statement here, and we see that we're doing temp, and then we have the %.1 LF, and this just means we have one decimal point, and LF refers to this temp variable, which means we're just printing out the temp variable, which means that we just get temp, and then we get our 1.0 with our single decimal place. And as you can see up here, that is A. So A is the answer to this question. And if we were to continue the execution of this program, we would notice that this is a void function, so nothing gets returned up into this main function. But one thing first is that this x would then get incremented to 14 after this line of code is executed. So technically this would be updated to 14, but since this x value does not get returned or used after the fact, that doesn't really have a significant impact on the result of the program. And since we move back up to this function, it's a void function, and as we continue this next line, we also have an x plus plus up here, which means this x will turn into a 13. And then we reach the end of our code without printing anything else. All right, so let's move on to the next question. So question 2, another code question asking us what the output of the following program is. So let's do the same process. So we get into our main function, we have our x and our y variables, and we'll keep track of those values. So we get 20 and 10. So then we have this trace fx function. And before we do this trace fx function, let's take a look at the code we're dealing with. So we enter this trace fx function, and we notice that it's void. So we're not returning any values to the main function. But we also see that the print statement is in the main function. So this means that anything that occurs down in this function is going to have no impact on the result of the x and y variables. So we'll talk about this just in a little bit as we move through the code, but keep that in mind as we move through. So let's do our process here. So we have x plus plus, so that means that a 20 is going to be here, and then it'll increment after the fact. Then we have plus plus y, which means y will be 11, plus 1. So then you have 11 plus 1 is 12. But remember, this is a void function. We're passing this to a void function, and there's no pass by address. So that means these x and y values are not linked. So anything that happens to the x and y values in this function is going to have no impact on the values in the main function. And since we're not returning anything, that means that this function pretty much is useless and is not doing anything for us, as it's just a void function. So that means we already have the values of our x and y. So after this tracefx gets executed, we could trace through it, but since it has no impact on the program, there's no point in wasting time on the exam trying to trace through it. So we have to remember that this x gets incremented after the fact. So we have a 21 and an 11. And so the print statement gets executed. We have x, and then we print out a 21 above that, and then we print out an 11 here. And if you notice that here, we have x 21 and y 11 in answer A. All right, moving on to the next question. All right, question 3, another code question. Which of the following is the output generated by the program? All right, let's do our little process here again. So we have our x and our y in main, and we know that this is 19 and 4 to start. So right away we see that we have our print statement. So this is the print statement that will result in our result, and we see that we have this little function call within it. So it's just a simple function call, so we just pass in x, which is 19, and the value of y, which is just 4, and then we pass that down into the make calc function. So this becomes 19 and this becomes 4. Notice that even though this says x and this says y, this says y and this says z, that doesn't matter at all, because those variables are completely unrelated as they are in different scopes. The thing that matters is the order in which you pass the parameters to this function. So this 19 goes to this y, and this 4 goes to the z. So as we track that down here, that is not x and y. That is the mistake I was just mentioning. This is y and z now. So y is 19 and z is 4. So this is just a super simple function here. Just making sure you remember your order of operations, and of course your integer division. That's always something to look out for. They try and trick you with that a lot. So we have our y divided by our z, which is 4. So remember, this is integer division. So we know 5 times 4 is 20, but 19 is less than that. So 19 divided by 4 is just 4 with a remainder of 4. And since it's integer division, we just truncate it. So we get 4 plus 1, which is just 5. So we return this 5, then gets returned up into this make calc function. So this 5 is up here, and that's what we're printing right here. So this 5 gets printed right here, and we see the 0.1. Oh, one important thing to note, since this is a double, we're returning a double. This is 5.000, however many zeros you want to consider there. So this is not just 5, it's technically a double as well. And since we're printing the double and we see that it's just a 0.1, so we're just printing 1 decimal point, that means our answer is going to be B, which is the result, and it's the result of this 5.0. Moving on to the next question. All right, question 4. Which of the following is the output generated by the program? Yet again. All right, this one looks very similar to the last one. And if you notice, values are the same. This is the same. Only difference is what we're doing in this make calc function. So we can kind of speed through this. We can do our x and our y. We know it's 19, and we know that's 4. So 19 and 4 here. And just like before, it's just the order that matters. So this is a 19, and this is a 4. So we want to keep track of our y and z, because that's what the variables are in this scope. And our y is 19, and our z is 4. So then we got to do our quick calculations here. So we have 19 divided by, and then we see this double here. Now what does that mean? this means we're doing an explicit type conversion, which means we're converting this to a double. And if you look at your order of operations sheet, this will occur before the division occurs. So that means this z is going to be a 4.0. So you might ask, why does that matter? Who cares about that? This matters because now we are no longer doing integer division, as we now have a double in here. So if either of the operands is a double or a float of some sort, then the integer division is no longer used, and we just do standard division that everyone knows and loves. And so if we do this calculation, we end up getting 4.75 as our answer. So that's what ends up getting passed back up into this main function. So we pass this 4.75 back up into this function, and just like before, we are printing out the result of 0.1 LF. And if you remember, that 0.1 means we are rounding to 1 decimal place. And if we round 4.75 to 1 decimal place, we get 4.8. So this is going to be result 4.8. And if we look over at our answers, this is going to be answer B. All right, moving on to question 5. Question 5. Which of the following is the output generated by the program? Yet another one. And if we see, looks just like the previous two ones, just a different function again. So we can do our x and our y up here. We know that's going to be 19 and 4. And this will be a 19 and 4. Pass it down into this function. And just like before, it's only the order that matters, not what the name of these parameters are. So that means y and z are just going to be 19 and 4. Sorry for my bad 9s there. All right, so we got to do this calculation yet again. So this one's a little different, just like before. So it's going to be 19 divided by 4 minus 1.0. All right, so order of operations are very important here. So obviously we're going to do our division first. So this is just 19 divided by 4. Both of these are integers, so guess what? We have to do integer division, which means that we get 4 with the remainder 4, and we truncate it. So our answer is just going to be 4 for that. So we get 4 minus 1.0. And 4 minus 1.0 is just going to be 3.0, because we use the type of the highest priority, which is going to be this double over here on the right. And anyways, we are returning a double. So that's so the 3.0 is what we want to return back up to the main function. So we will return this 3.0 back up here. Then just as before, we have just 1 decimal place that we're doing, so it's a result 3.0. And if you look at our answers, that is A. So we get A for question 5. Moving on to the next question. Question 6. Which of the following is the output generated by this program? So now we finally have a little different program. This one looks maybe a little trickier. See some pass by address down here that we'll have to keep our eye out for, as that can get a little tricky, a little hard for some people to try and wrap their heads around at first, especially. So let's stick to our standard process that we know and feel comfortable with. So we'll keep track of our variables just like before. We get 22 and we get 8. And so now we see that this function actually does return a value, and it is passing a value into it. And if you pay attention to your core standards, you'll know that this is not, the best. You really shouldn't be doing this according to core standards, but on these exams, they don't care so much about core standards, as they're trying to trick you into things to make you trace. Don't ask me why, but that's just how it goes for the class. They try and trick you with some of these harder things. So we want to pay attention to the order here, because we're used to doing just x and just y, but now we have y then x, so that's a little tricky. You got to keep your eye out for that. So 8, and then we're passing the address of x here. So we know that this address of x is going to be this field right here. So you'll have to bear with me here, but we'll move these down into this function. So we have our a and our b. So we know a is just a standard old integer, whereas the b is going to be a pointer, and this pointer is going to point up to this x value, sorry, not the y value, the x value, because that's what the second thing is, because we're passing the address of x to b, to star b. So that means this is pointing to this value, which means that these two values are linked. So we have our x and our b, which are linked. So when these are linked values, that means anything that happens to b is going to happen to x as well, because they are referring to the same address in memory. So we got to be careful of that as we trace through this code. So when we go back down to the passing test, we see that we have this temp variable that we also need to keep track of. All right, so let's start off. So we can put our b, might as well put the value in. We just have to remember anytime we update this b value, we got to update the x value too. So we do 8 plus, and then we see the star b, and what all that means is we get the value at b, and we know that the value at b, for clarity, I'll put a star here, as this is technically star b, because if we were just doing b, that would be the address of x, which would just be a bunch of random numbers. But star b, as we know, is just 22. So that means temp is just going to be 30. So we get 30 as a result of 8 plus 22. So then we see star b equals temp minus star b. So we know temp is 30, and we know star b is going to be 22. And we know 30 minus 22 is 8. And so star b now becomes 8. And remember, since we updated star b, this is the same as x, because this is referring to the address of x. So that means we also have to update x to be 8. So now x becomes 8. And then the last thing we got to do in this function is we do a minus equals temp. And this is the same thing as saying a equals a minus temp. So we know a is going to be 8, and we know temp is 30. So we get 8 minus 30. So the result of this calculation is negative 22. So we're returning a, and we know a is negative 22. So this will get passed back into this function up here, and so that's what gets returned. And we see that the return value, which now occupies where this passing test was, is going to be set equal to y. So now we know that y is going to be, I'm going to erase this just because it's taking up some space, but we know that y is going to be negative 22, as that's the value that was returned by this passing test function. Okay, so now we finally get to our print statement, and we see that we're just printing x, and then we're just printing y. And we see x is 8 and y is negative 22. So if we look at our answers, we get A. Alright, so that was a little of a tricky one, as they had some pass by address in there. But hopefully as you start to practice pass by address some more, you'll get more familiarity with it. Just the most important thing to remember is that when you see this address of x and the star b, because this is keeping the address, that anytime you update star b, that's also going to update x. So that's the most important thing to keep in mind as we're working through a pass by address type problem. So we'll move on to the next question now. All right, we are now on question 7, which is another coding tracing type question. Alrighty, so let's just do our typical thing here. So we got values of A, B, and C. So we see that A is going to be 2, B is 4, and we still do not know the value of C. So it is unknown what that value is. And we also have this format one. So we got lots of variables in this question. And so right off the bat, we see this SQRT. And if you know your math and you see that the math library is included up here, this means that we are using the square root function. So we'll just take, the way this works is it just takes the square root of whatever the parameter is that gets passed through. So let's calculate what that parameter is. So we get 2 times 2 plus 4 times 4. So that's just a simple little math thing there. So that's just going to be 20. So square root of 20, what in the world is that? So you can use your calculator on this, and if you use your calculator, you'll know that it is equal to, so the square root of 20 equals 4.4721. And not all, this semester they were allowed to use calculators. When I took the course, because it was in person, you were not allowed to use calculators, but they would still sometimes give you something like this, so you'd have to kind of guesstimate what the value is. So we know that the square root of 16 is going to be, so the square root of 16 is 4, obviously, and the square root of 25 is 5. And so we know that the square root of 20 is going to be somewhere between 4, and 5. So it would be somewhere in that range. So if you have a calculator, obviously you know exactly what the value is. You can just calculate it. But if you do not have a calculator, then you'll have to do some sort of estimation as to what the value might be. So this value will be put up here into C. We don't have enough room, so I won't write it up there. But we can see that it gets stored into C right here because it says C equals this. So then the next thing that happens is we update this format function. So we say format is equal to C. So we can also just draw, well, I guess we could write it out. We could do, so it's 4.4721, or if we didn't have our calculator, we know it's between 4 and 5. So then our result here is going to ask us, we have this kind of weird looking printf statement here. So let's break this down. So what we see here is we have point. So point star. So what in the world is this star thing doing here? So what this star thing is it'll take this first variable in the parameter list, and it'll use that as the value in this printf flag here. So we know this is the rounding flag because it comes after the point right there. So this will be point star. So whatever format is, and we know format. Oh, important thing to note, I was not paying attention. This format is an integer, and since it's an integer, you have got to round it down. So even though this is 4.4721 or whatever, we have to round it down, so it's just a 4. It is not 4.4721 because it is just an integer. It is not a double. So my bad on that, missed that. But that'll help us here because we know that this is a 4. So that means we know that this is going to be 4 decimal places. And then we know that C is this 4.4721, and conveniently I only used 4 decimal places, probably because I knew what the answer was already. But anyways, we see that this indeed is our answer right here, B. And so you might be asking, well, what if I didn't have a calculator? How would I know that? So this takes a little bit of trust. Don't think they'd quite ask you something like this on an exam without a calculator. But since we do know the values between 4 and 5, and when we round down this format, we know it'll round down to this 4 here. So we know that it'll be 4 decimal places, and this is the only one with 4 decimal places between 4 and 5. So you can take a reasonably strong assumption that that'll be the correct answer. Obviously, you have this none of above, which throws in a bit of a wild card with that, but hopefully they are allowing you to have a calculator in whatever semester you're taking this. I can't say for sure. Be sure to check the course website or the Brightspace or whatever is used to ensure that you can or cannot use calculators. All right, moving on to the next question. We got question 8 here. Question 8, another coding question. It's asking us what the following is. Which of the following is the output generated by the program yet again? All right, so let's keep track of our variables here. So we got A, that's a terrible A. We got A, B, and C. So we know A is 0.5, B is 3.0, and C is an integer with a value of 2. And those are all not the right color there, so let's change that really quick. Oh, and of course our A also gets changed. Whoops. All right, getting back to what we were doing. All right, so now we move on to our next line of code down here. So we see this A plus equals B divided by C. So we'll just write out this plus equal, remember, means that it's going to be A plus B divided by C, and we'll store that back into A. So that'll mean we get 0.5 plus B, which is 3.0 divided by 2. So order of operations, we've got to do our division first. So remember that when we do our division, that if either of the values is an integer value, or I mean not an integer value, a float or a decimal of some sort, or a double, then that means that we'll just do standard division. Otherwise, if both of them are integers, then we do integer division. And as we see here, one of them is indeed a decimal value, so we do just normal division. So we get a value of 1.5 for here. So we get 0.5 plus 1.5, which as we know is 2.0. We store that into A, so A now has a value of 2.0. So then we move on to the next line, and we see yet another of the same similar type of thing. So we do 0.5 plus, which is the value of A. So we do, and now we see this explicit typecast, and we know that this explicit typecast comes before this division occurs, So we will want to make sure we do that because b is indeed a float beforehand. So when we do the explicit typecast on b, that means this becomes an integer 3, and we divided that by an integer 2. And as we know, this is integer division, as both of these are integers. So this is just the result of that operation is merely just a 1. So this will just be 0.5 plus 1, which will give us a value that is, oh, I did not use the right value here. Whoops. That is not 0.5. This should be 2.0 as we updated the value of a. I should cross that out so I don't get confused again. Okay, my bad there, my bad. So this is a 2.0 plus 1, and that'll give us a value of 3. That is now our new value of a as we update it yet again, and we'll cross this out so we don't get confused again. All right, moving on to the next line. We get c equals b divided by c plus 0.5. So we know that b is 3.0, we know that c is 2, and we add 0.5 to this all. So we see that we're not doing integer division because this is not an integer. So we just get 1.5 plus 0.5, and as we know, 1.5 plus 0.5 is just 2.0. But since c is an integer, be sure to pay attention to that. C is an integer, so this is just 2. It is not 2.0 because it is just an integer. And so c didn't really change its value, but we can still cross it out so we don't get confused. All right, our last line of execution, our last calculation here is a plus equals c, which means we're just doing a plus c. And we now know that a is 3.0, and we know that c is 2. And so this will just be 5.0, and since a is a float, this will stay a decimal, and so a now gets updated to 5.0. So a lot of updating of a in this one. So we have our final values of all 3 variables, and it's only asking us what the value of a is in this thing to and we round it to just a single decimal point, and we know that a is indeed 5.0. So our answer is B, 5.0. All right, next question. All right, question 9. Which of the following is the output generated by the program? All right, probably getting sick of doing these coding questions by now. All right, so let's just do our same process that we've been doing the whole time. We'll write down all of our variables here, and then we'll write down their starting values for each variable. So even though we see that this double is 3, this is actually 3.0 because it is a double, and that 0 obviously extends to infinity, or an infinite number of zeros rather. It doesn't go to infinity. There's an infinite number of zeros. And then this x is a 2, y is a 10. Okay, so now we have our first times equals and divide equals. These operate in the same way that plus equals and minus equals work, in that this will just be x times, and then we got to remember this will all be in parentheses, 5 plus a minus b, like that. So that's an important thing to remember, is that there's technically going to be parentheses around both of these arguments when you actually do these calculations. So let's do those calculations. So we know x is going to be 2. Then we'll do times 5 plus a, which is 15.25, minus b, which is 3.0. And after you do all of the math there, just some simple adding, subtracting, multiplication, we get that this is equal to 34.5. But notice that x is an integer here, and this is not an integer. So we gotta convert this to an integer, and we know when we convert this to an integer that the decimal gets truncated, so this just turns into a 34. You do not do your standard rounding. What you do instead is that you floor it to the nearest value. So that floors to 34, so x now is 34. Cool. All right, so now we have this y divided by equals 2 plus a divided by b. So let's write that out more for some clarity. So we know that this is y divided by, and then all in parentheses, 2 plus a divided by b. Okay, so then if we actually stick some values into that expression, we know that y is 10 divided by 2 plus 15.25 divided by 3.0, and then we have to solve this. And we notice that both of these are actually doubles, so we just do standard division there. It does not, since both of these are doubles, we just do standard division. No integer division is occurring there. Okay, So if you were given a calculator on the exam, not all semesters have been given calculators before. Be sure to double check what you're allowed to. If you're given a calculator, then this operation is pretty easy just to do all on your calculator. But if you don't have a calculator, you know that we're doing 15 divided by 3 here. And we know 15 divided by 3 is just 5. And then the rest of it is just going to be 0.25 divided by 3. And we know that this is just going to be, 1 divided by 12, which we know is less than 0.1. So we know that it's somewhere between 5 and 5.1 if we had no calculator and we had to kind of guesstimate where it is. But we'll move forward assuming that you do have a calculator. And so you'll get 10 divided by 7.083. And so if you didn't have a calculator, you would know that this is going to be between 7 and 7.1. And you'll see why that doesn't really matter, as this y is an integer, so integer division is going to occur here in that we do 10 divided by 7.083, but this just gets turned into a 1 because 7 only goes into 10 one time with the remainder of 3 point a bunch of numbers there. So we know that y, the result of this calculation, is just going to equal 1 for the intents and purposes of what we're doing here. So this y is a 1, and so we have 34 and we have 1 here. And if we see that here, that is our answer, A, up at the top there. All right, moving on to question 10. All right, question 10, we have our first introduction to defined constants up here near the top. So we see this pi, we see volume, and we see surface area is what that is going to be standing for. And so, all right, let's get started on this. So let's just do our standard thing of we'll write our A, B, and we also have an, oh, just kidding, that's the previous problem, my bad. We just have one variable here. It's just radius. How nice. Just radius. So we have radius, and that is 2.0. Okay, so we'll plug that in down here, and we know radius is 2.0. And this pow, if you remember, in this math.h library up here, pow is the power. So the way this works is we'll just have 2.0 to the third power. And as we know, 2.0 to the third power is going to be 8.0, as we have to keep our the type of variable that we had, because it was a double, so that remains a double, so it's still 8.0. So then what we are left with is we have volume, which is a defined constant, as we'll see at the top, times 8.0. Okay, so we gotta kind of figure out what this volume is. So volume, as we see up here, is 4 divided by 3 times pi. So what we got to do is we got to put in this pi value. So down here at the bottom, what we can do is we know volume is 4 divided by 3 times pi, and then times this result that we already calculated. We really should have done this calculation, actually, now that I think about it, after the fact, but it won't affect us because we're just doing left to right and nothing gets messed up. But do make sure you follow order of operations in that you wait to do the power calculation a little bit later. So we do our order of operations, and we notice that 4 divided by 3, those are both integers, so we're doing integer division. So the result of that is just 1 times pi, and we know what pi is. That is 3.1416. And then we multiply that by the result of the pow, which is 8.0. And so if you are allowed a calculator, and it is important to note, when they took this test, they were allowed a calculator, but not all semesters were allowed a calculator. When I took the class, I could not use a calculator. So be sure to keep up with what the instructor is saying for this semester if you are or are not allowed to use a calculator. So if you use a calculator, you know that it's 25.133. And if you don't have a calculator, well, then you'll have to break out the old-fashioned elementary school level multiplication like so, and you can work through that yourself. Hopefully you somewhat remember how to do that, but that is what you'll have to do if you are not allowed a calculator. Okay, so we know that the result of this entire little expression here is 25.133, and if we notice here, we're only rounding this to 2 decimal places, And so we are just rounding this, so this gets rounded to 25.13. And if we see here, that is our answer B for 10. We get B. All right, next question. All right, this next question is similar to the last one. We see the same constants defined. We even see our same little radius value right here, just 2.0. And we'll be sure to actually properly follow the order of operations on this one. So surface area, we know if we look up there at the top, that is 3 times volume. Then we multiply times pow, and we know radius is 2.0, and this time we're going to a power of 2. Alright, so let's work through this. So 3 times volume, and so we know volume is going to be 3 times 4 divided by 3 times pi, and we know what pi is. We know that pi is 3.1416. I'm going to make this division a little more clear. And then we multiply this times pow 2.0 comma 2 over here on the right. So then we got to do just our order of operations, and since we just have a bunch of multiplication and division and such, we'll just go from left to right. So that is important that we do pay attention and that we actually do go left to right, because you will see very shortly how that makes a difference. As our first thing we do is 3 times 4, which is 12, as that occurs before the division. So we do 12, then we divide by 3, then multiply by 3.1416, and times pow 2.0 comma 2. So then we do 12 divided by 3, both of them are integers, so it's integer division, but we know that 12 goes into 3 with no remainder, so it's just 4. Nothing too complicated about that. Times our 3.1416 times pow 2.0 comma 2. And like I've mentioned throughout the various problems here, is that when they took this class, they were allowed to use a calculator. So some of these, or this semester, they were allowed to use a calculator. Your current semester that you're in, I don't know for sure. I can't say for sure if you are or not. So be sure to check with the instructor if you are allowed to use a calculator or not. If you are, that 4 times 3.1416 is pretty simple. Otherwise, like I said before, you'll have to break out the elementary school math and do some multiplication like that. But we're not going to do that for now. And so we know we can figure out what that value is on the left, and then we do this. We should also do this pow 2.0 comma 2. And so this is just 2.0 to the second power, which is just 4. So we're just multiplying by 4 over here. So then when we do this entire thing together, we will get a value of 50.266. And so as we see back up here, we're rounding this to 2 decimal places. We're rounding that to 2 decimal places, so 50.2. And notice that this is rounding. This is not truncate like what happens with integers. So we round up, since this is a 6, to 27. And so that is our answer A up here for question 11. Now we'll move on to the next one. All right, question 12, some more code tracing fun stuff. This one's a little different than the previous ones we've had, so let's dive right on into it. So we have X, we have Y, and we have Z. So we know that X is going to be 45, we know that Y is going to be 17, and we do not yet know what Z is going to be. So let's figure out what Z is going to be. So we got to jump into here. So we know that X, we're going to pass in a value of 45 here. And then for the second parameter, we're going to pass in this. And what does this mean? Well, this means that we got to execute this first, see what this returns, as it returns an int here. And then that will get returned, that'll get passed into this function, and then this function will get executed twice. So at the end of the day, we'll execute this shift-fx function twice throughout the execution of this code. So let's move on to this little this next shift-f one, shift-fx, excuse me. So this y we know is a 17, and this x is a 45. And like I've mentioned in some of the previous ones, the order matters, but the actual letter or variable name that is used does not matter in terms of the linkage for these variables. So we have a and a b down here, and so we know that a is going to be that 17. We know that b is going to be that 45 on our first pass through this function. And so let's figure out what that is all going to work out to be. So we have 17 plus 45 modulus 17 divided by 2. So we got to follow our order of operations here. So we'll do our 17 plus 45 first. So that gives us 62 mod 17 divided by 2. And we still have to follow order of operations. So we got to do the 62 mod 17 first. And if you're wondering how in the world do I calculate what that is, we'll do a little division over here on the left. So 17 and 62. So we know that 17 can go into 62 3 times. So when we do 17 times 3, that's 51. And this gives us a remainder of 11. And this 11 is the answer to our modulus of 16 divided by 17, as modulus is merely the remainder of the division. So this means that we have 11 divided by 2. And so we know that 11 divided by 2, that is integer division. So we will just get an answer of 5 here as we round down our answer, because we have to floor it. So that means this 5 is going to get passed back up into this function up here, which means that this shift fx here, this is just going to result in a 5 up here. So then we have to run the shift fx function yet again. So to run that again, let's clean up all of our code here, and let's do it again. So this time we're passing in a value of 45 for A. We're passing in a value of 5 for B. So let's do it again. So we get our 45 plus 5 modulus 45 divided by 2. So we know that this is going to be 50 mod 45 divided by 2. And we know that 45 can only go into 50 one time cleanly, and we get a remainder of 5. So that means 50 mod 5, or 50 mod 45 rather, is just going to be 5 divided by 2. And we know from before that this is integer division. So 5 divided by 2 is going to give you 2.5, but you round that down to get 2. Since this is an integer right here, 2. So then we pass that back up into the function, and we get z is a value of 2. Then we move on down to our print function, and we see that we're printing z, and we know z is 2. So that's our answer, is C. Z equals 2. So next question. Alright, so now we are on question 13. Almost done with some of these coding questions. Just over halfway through this exam. So let's see here. So we have just a main function here, and we got another function. So let's just do our typical tracing of our code here. So we know x is going to be 14, y is going to be 27, and we do not yet know what the value of z is going to be. And so this looks very similar to what we did before, where we are calling the shift f function twice. And so let's just get right into it then. So this y we know is 27, this x right there is 14, and this y is 27. So the first thing that happens is this interior one. This interior shift fx is going to get executed with the 27 and the 14. So we'll move that down into A and B. So we get 27 and 14. Alright, so then let's do the calculation here, and I believe that this is the same thing that we were doing in this last problem. So it's adding it, then modding it, then divide by 2. So we'll write all of them out right there. And so we know that this is just going to be 41 mod 27 divided by 2. And so we know that 27 only goes into 41 once cleanly. And then we get a remainder of 14, because if we do our little division over here on the side real quick, so we know that 27 times 1 there is going to be 27, and then we subtract that and we get a remainder of 14, and that's the answer to our modulus. So we get 14 divided by 2, and that's just 7. It's integer division, but we know that there's no remainder, so it doesn't have an impact really on what happens here. So then we pass this 7 back up. Oh, yeah, 1 second, sorry. I'm just checking my notes, making sure that we did that properly. So yes, so we pass this 7 back up into this main function. And so we know that this will result in a value of 7. So then we pass in the 7 and the 27 down into the function below. So we'll get this out of our way as we don't care about that anymore. So now we'll run this function again. We'll get 7 and 27. And so let's just do the calculation. So we get 7 plus 27 mod 7 divided by 2. So 7 plus 27, that's going to be 34 mod 7 divided by 2. So we know, let's figure out our modulus, 734. So we know that 7 times 5 is 35, but that's one too many, so we have to do 7 times 4, which is 28. And then if we subtract those, we get a remainder of 6. So we know that the value of the modulus is 6. So we do 6 divided by 2, and that's just 3. It is integer division, but like I said, there's no remainder, so it's just a value of 3. So then 3 gets passed back up into this function. So this whole thing becomes 3, which then gets stored into z. So z becomes 3, and that is our answer. Z is 3, which is B, as we see up there on the top. Now let's move on to our next question. Alright, we are finally through most of those coding questions, and now we're just on to the true-false, which will hopefully be maybe a little bit more smooth sailing, maybe a little faster, hopefully. Alright, so true-false. So as you see here, we have these lovely none of the aboves on all of these. So my favorite way to make it way through these true-false questions is just to take it one at a time, see if it's true or false. So, and one of the most important things to pay attention to is what this is asking. Sometimes it'll ask if it's true, sometimes it'll ask if it's false. So this one's asking, which of the following is true? So let's read through our first one. So it asks it states that one benefit to the use of machine languages is improved programming efficiency compared to a symbolic language. So, machine languages are actually going to be much harder to work with, as it's like assembly, which C gets compiled down into machine language, which is something like assembly, which is then read by the machine. And assembly is much more complicated than a symbolic language. A symbolic language is designed to be more similar to English and easier for someone to program and use. So we do know that this is indeed false, as machine languages do not improve programming efficiency, as they are much harder to use and they use a lot more code than a symbolic language like C. And since C ends up getting compiled down into assembly, they pretty much have the same productive efficiency in the end anyways. Okay, so next, B. The process of converting a high-level language to a machine language is known as compilation. And so this is indeed true, actually. This is true, as when you run, say on Guru, when you run GCC, this C code, just like I was kind of talking about in answer A there, is being compiled into low-level assembly, and this is known as compilation, as the question mentions. And just to cover our basis, we'll check out C as well. And so C says code written in a low-level programming language, which is something like assembly, like we said, is portable to many different computers. And this is kind of a tricky question. This gets touched on more in advanced level computer science or ECE classes. But this is false, as low-level programming languages are actually super specific to the processor / computer and OS that they're on. So something that's using x64 architecture is not going to work on an ARM Cortex. Those words probably don't mean much to most of you, and you don't need to know what those mean. But just know that anything in a low-level programming language, the assembly is pretty specific to the processor architecture that's on the computer. So that is indeed false. So we do know that B is the correct answer. All right, moving on to 15. All right, 15. See, now this one, got to pay attention, because this one's asking which one is false, not which one is true. So let's figure out which one is false. So let's check out this first answer option. And A states that the width modifier for the output of a value must be large enough to account for the integral value of the number, the decimal point, and the number of digits in the decimal position. So this integral value of the number, this is the same thing as just saying the integer value. And so is this statement true or is this statement false? So if you think about it for a little bit, this statement is actually true. As the best way to prove this one is just to use a counterexample. So if we were to use %2d, so what this is for our printf statement. So this 2 here, what the 2 is a width modifier, which is mentioned in this question here. This is the width modifier. So if we use the %2d on, say, 110, then the value will overflow the true number of spaces, as this width modifier is going to reserve 2 spaces, but this number takes up 3 spaces. So it overflows the 2 spaces that are going to be used, and thus we know that this width modifier must be wide enough to account for all of the digits, all of the decimal points, as it also mentions decimal points, and the number of digits in the entire number. Otherwise it'll overflow and it won't behave like we think it will, as it'll take up more space than what we think. That's kind of a weird question, but just kind of think about that counterexample, and you can also think about something like that uses some decimals as well. All right, so let's move on B. So we know A is not true, or A is true, which makes it not one of the answers. So B says the conversion codes selected for a placeholder depends on the data type of the value to be displayed in a printf statement. And this is indeed true. Whoops, that's not the right color. This is indeed true, as for integers you have to use, if you remember, so the conversion code, that is going to be this D. So when you do %d in a printf statement, the D is what is considered the conversion code. But this is going to be different for a float. A float is going to use something like %f, and then a double, I believe, is going to use %lf. So as you can see, the data type, which is going to be an integer, a float, or a double, does depend, or the conversion code does depend on this data type, as there's different conversion codes for all of these data types. So this is indeed true. So C, does this mean C is true, or does this mean it's going to be none of the above? Or I guess technically C is false. So let's take a read. So a precision modifier may be used to limit the number of digits to display in an integer value. So the precision modifier, that's kind of like, well, what is a precision modifier? It's not the most intuitive name in the world, but a precision modifier is something, if we have like 0.2lf, for example, this 2 here is the precision modifier, as it determines the number of decimals that we round to. And number of decimals we round to, well, that is obviously for decimal values, and we know integer values don't have any decimal points. So why would this be true then? Because a precision modifier, if you pull up a compiler and you try to use %2d on an integer value, you'll notice I'm pretty certain that that'll actually throw an error at you, because it's not allowed, since integers do not have decimals. So this is indeed false. Whoops, that's not an X. This is false, and since we're looking for the false answer, that makes this the correct answer for this question. So this one was kind of just testing you on your knowledge of the printf statement. Just make sure you know what the name of all of those flags are, like the precision modifier, the width modifier, and everything related to that, as these questions will certainly quiz you on that knowledge. So let's move on to the next one. All right, question 16 asks us, which of the following statements regarding constant data is false? So very important, which one is false, not which one is true. So constant data. What is constant data? So this is going to be something like literal constants or defined constants. So let's take a peek at the first question, or the first answer option rather. First one says a literal constant is an unnamed constant used to specify data. This is indeed true, actually. This is true, as a literal constant is just going to be a number or a character. So for example, if we have this function called MindFunction, and this function takes 2 integers, and we pass in, or actually let's say it takes an integer and a double. So we pass in a 3 and a 4.1. This 3 and this 4.1 are both considered literal constants, because there's no name that's representing them. There's no like constant name, and there's no variable name or anything. These are both literal constants, and as you see here, this is a key word here, unnamed constant. So obviously these are both unnamed constant, as 3 is not a name. So we know that that is indeed true, which does not make it a correct answer. So B, what about B? So it says, while variables have data types, the values represented by constants do not. And when it says constants, this could mean literal constants, like these ones we were talking about before, or this could also refer to our hashtag define, yada, yada, yada. But this is false, actually, which makes it a correct answer, as both those types of constants, as well as this const, this is one that you probably won't actually use in your code, but it does exist in the C language, where you do const, and then I do believe, I do believe const, and then you'll actually specify the data type afterwards, int, and then you would say whatever the name of it is, maybe width, and then you say it equals 3. So this does indeed actually carry a data type along with it. And if we were to use a literal constant, this technically would have a sort of data type, because if you were to do 2 integers, then that would result in integer division. This is technically a float of some sort, even though you're not explicitly defining it as a float. So this does mean that constants do actually have data types. This is probably the most concrete example of it, as we actually define the data type for this type of constant. Okay, and just to cover our bases, we'll check out C, and it says that a character constant is enclosed in single quotes, and this is just a matter of, this is just testing on your knowledge, and this is actually true, as if you're trying to say, char foo equals C, you just do 1 quote C, and if you were to use double quotes, that would not work, because that is defining a char, an array of characters, which is considered a string in other languages. So you have to use single quotes for a character constant. So we know that B is indeed our correct answer for this question. Moving on to the next one. Question 17 asks us, which of the following statements is true? The main function begins, there's a typo there, not beings. The main function begins with a section for preprocessor directives. This is just testing you on your knowledge of what C code looks like, and we know that this is actually false. This is false, because these preprocessor directives, which are stuff such as pound include or pound define, these actually occur above the main function. They do not occur within the main function. So anything that has these pound is a preprocessor directive, and it occurs above main. It does not occur in main. So this actually gets executed before the main function gets executed. So B, only the code found in the executable statement of the main function is considered to be the body of the function. This is also going to be false. And why is this false, you might ask? That's because the body of your main function, or any function for that matter, does not just contain executable statements. It also contains initializations of variables. It can include printing stuff. Obviously, if you're going to execute statements, you need to be able to initialize variables, and all of that occurs within the main, or within the body of the function itself. And then C, as the GCC compiler, as found on Guru, will require that main be a void function. And if you actually just take a look at C code, you'll see that this is false. And why is this false? Well, main is actually going to be an integer function. It returns an integer, which may seem kind of weird to some of you, but we'll learn in some of your later classes, and maybe you'll learn in this class as well, that the integer that is returned is just a code that that can be returned that determines if main was ran successfully, or if it failed, or if it exited, or what have you. You can Google that some more if you're interested. So since those three are wrong, then we get our first none of the above for this exam. Everyone's favorite none of the above always makes you second guess your answers, but that is indeed our answer here, as we know the other three are most definitely false. Moving on to the next question. All right, question 18. another true-false question asks us, which of the following statements regarding operators in the C programming language is false? Make sure we pay attention to that falseness. And the first one, so we're talking about operators, and it says when two operators with the same precedence occur in an expression and their associativity is left to right, then the left operator is evaluated first. And this is kind of just testing you on your knowledge of stuff you've learned in lecture. And this is actually true. This is kind of a little bit of a weird question, but just remember that most operators like this. Most operators are like this, and they are similar to PEMDAS and just the standard math order of operations. So when you say the associativity is left to right, then that just means we're moving left to right. So that means our left operator gets evaluated first. All right, so B. All of the compound assignment operators share the same level of operator precedence. So what is a compound assignment operator? What in the world does that mean? That is something like plus equals, or maybe minus equals, or times equals, anything like that. Those are all considered compound assignment operators. And something handy that you have for this exam is the operator sheet with all of the precedents. And if you look at that sheet, you'll notice that all of these assignment operators do indeed share the same level of precedence. So this is actually going to be true. And then C, operator precedence can be used to bind operators to operands, and from that will determine the order of operations in an expression. Kind of a wordy question. Lots of operators, lots of operands. So what all is going on in this? So if we give this a little thought, so we do actually know that this is going to be true. And so why is this true, you might ask? Operator precedence is effectively the same as the order of operations, like I mentioned before, order of operations in math. Just, there's a lot more new operators, like the compound assignment. And so as we know from our math, then the operator precedence is just the same as the order of operations. And so that just makes this true, pretty much. Kind of a weird one, but we know that that is indeed true. So that leaves us with none of the above, which makes it 2 in a row. How gross is that? So yet another none of the above. Moving on to the next one. All right, question 19. Which of the following statement regarding expressions is false? So let's see. So we're dealing with something. Which one's false? It asks. Which one is false? So A asks us, or A states that the value of the postfix increment expression is determined before the variable is increased. And this is just texting you on your knowledge. And if you just know your ironically prefixes for your words for the English language, you'll see post. And what do we know about post? That means just kidding. Okay, sorry. Never mind. Okay, so this is indeed true, actually. Sorry, I had to take a look at my notes there. So I kind of confused myself there too. But, why is this true? As I was just talking about how it's post and then it's before. But that is actually true. And the best way to think about this is just of an example. So say we have, my function here, and we pass in x plus plus. So we know that this plus plus is actually going to be, that is considered a postfix increment expression. And so when it says the value of the postfix increment expression, that's asking what gets passed in effectively into this function. And so what gets passed in is just the value of x, because the postfix means that it happens after. And so we're effectively passing in the original value of x into this function, and then after the function is executed, then it gets increased. And so we're using the previous value of x when we're evaluating the function, which is the same as saying that the value of this expression is determined before it's increased, because the variable gets increased after the fact. So kind of that one's a little tricky. It's just kind of overly wordy, but that is indeed true, as I mentioned before. So B, the operand in a postfix or prefix expression must be a variable. And this is something that you can simply just try on a compiler. Obviously, don't have a compiler on the exam, but this kind of makes a little sense. So this is indeed true, because you cannot do things like 3 plus plus, because what in the world would that happen? What would that mean? Because 3 is not anything that's getting stored, so this would have no use anyways, because it's not getting stored into anything. So we know that this has to be a variable like x, so this has to be x plus plus. We can't do 3 plus plus, can't do 2 plus plus, can't do 3.1 plus plus. None of those will work. If you try that in your code, you'll probably get some sort of error, as that's not allowed, and it would be pointless functionality since it's not getting stored into anything. All right, C. The result of an expression is undefined when it attempts to modify a single variable more than once. And this is a tricky question. I remember this caused some questions in the class forum several times. Lots of back and forth debate about if this one's true or false. And so this one actually is going to be true. So why is this true? So if you look through the C specifications, so if you'll like Google and you look through C and stuff, the C language, I did it for you so you don't have to look yourself. But this is actually considered undefined behavior. I remember my professor in this class, when I took the class, talked about how this is going to result in undefined behavior in C. And so what is this even talking about? So this is talking about a scenario where you have something like int x equals 2. Then you say x equals x plus plus. This is a really weird statement, because we're saying x equals x and then plus plus. And so we're updating the value of x twice in this single expression, which is what this is talking about up here. And so this can behave really weird, and thus the C language says that it is undefined, or it's just not predictable, as it's not reproducible across different compilers and such. So this is something you kind of just have to know. It's just a really weird thing. You would never want to do this in your code anyways, but this is indeed undefined behavior. And when it says that it's undefined, it doesn't necessarily mean that it's like 1 divided by 0, something like that. It more means that we don't know what the behavior is going to result in. So just know that this is indeed true. And with all those being wrong, that means we have, get this, 3 in a row. 3 in a row on the none of the aboves. How cruel is that? No one likes the none of the aboves, and yet we have 3 in a row. Certainly making you do some second guessing while you're doing the exam. So let's move on to our next one. Hopefully it's not none of the above. All right, question 20. Another true-false question here. This one's asking us which of the following statements regarding user-defined functions is false. Keyword, oops, that is not the color we've been using. Keyword false there. All right, so let's take a look at our first A statement here. And it says that a called function may return at most 1 value to the main function per call. And if you've done some programming, then you probably know that this is indeed true, as in the C language at least, you cannot return multiple values. So you couldn't do like return 2, 3. That's not allowed. That's not how that works in the C language. If you've ever used Python before, you can actually return multiple values. But in C, you cannot do that. You can only return 1 single value to the main function. If you were wanting to return multiple values to the main function, you have to use pass by address. But you're not technically returning values when you use pass by address, as you're just updating the values in memory, which is not the same as returning, as a function can only return a singular value. So then let's look at B. The control of a program always returns from the called function to the main function. So what does that mean? So this is saying that if we run a function, then it'll always just return to the main function no matter where we call it. And this is actually false. So why is this false? So say we called a function from another function. Then this would actually return to the previous function, not main. So let's look at a little example here so that makes a little more sense. So say we have this function myFoo here, and it returns some value, blah, blah, blah. And then we also have my bar over here, also another function. And in this function, we call my foo, and then we return some value. And then in our main function at the top, I'm not including brackets and stuff, but just know that brackets are there. This is more of a pseudocode. This is horrible handwriting. I am very sorry. I'm trying to write this a little too fast. But say in our main function up here, we call my bar. So the way this code's going to run through is we're going to hit this my bar. So we're going to go down to this function. And in this function, we call my foo. So we go into another function. We do whatever happens in my foo, and it returns. But what happens is this returns to where my foo was called. This does not return all the way back to main. So this returns to my foo, which then executes, and then returns, and then we go back to main. So this is a counterexample to this question, as when we call my foo here, the control returns to this user-defined function. It does not return to the main function, which means that B is indeed false, which will likely make it the right answer. We just got to make sure C is not right for whatever reason, just to cover our basis, and just in case you thought C was a correct answer. And so C says data sent from the main function to the function being called will be received in the same order in which it is passed. And I have stressed this numerous times throughout all the code tracing problems earlier in this exam. So if you're confused, look back on those. But this is indeed true. This is true. This is very important. Lots of people new to coding kind of struggle with this idea at first, especially when they try to trick you with it. But if we have this function foo, and we pass in 3 and 4, and then foo is defined down here as having int x and int y, it does not matter what the name of x is, what the name of y is, what the name of any variables in this main function up here are, or in the calling function. All that matters is what the order of these parameters is. So the first parameter just gets passed to the first parameter right down here, and then the second parameter gets passed to the second parameter. So order does indeed matter. It is extremely important. That is exactly how the parameters are determined. So C is true, and so that we know B is false, which means that it is the correct answer. All right, cool. Moving on to question 21. Okay, question 21 is another true-false, and it is asking us, which of the following statements regarding parameters and user-defined functions is true? So it's asking us which one is true. Keyword true, of course. So the first one says, answer option A states that parameters being received by a function will be commented to the right of where they're defined. So this is just simply a course standards question. And if you remember your course standards, this is false. This actually is false. And why is this false? You are supposed to comment it, but you do it above the function. You have like a function header that occurs above the function. You don't want to comment to the right or the parameters. We're talking about the parameters here. You don't want to comment to the right of where the parameters are defined. That's going to could cause some weird errors depending on how you do it. But in your function header above it, there's a space for the parameters where you can just say what they're defined as. So just remember that course standard. As if when you're coding, you'll have to do your function header anyways. All right, so moving on to B. It states that a variable declared in the local declaration section of a function can have the same identifier as one of the parameters of that same function. Keyword there, same function. So we have, basically what this is saying is we have we have a variable and we have a parameter, both within the same function that have the same name. So what would that look like? That would look something like this. So we have foo, and then we have int bar, and then I guess we'll include our braces here for once. And then in here we have double bar equals 3. So we have two things, both named bar, different data types, different values. What in the world? This is not going to quite work right. So that is illegal. If you try to do that in C, it'll get all mad at you. The compiler will throw some errors probably and say, you have two variables that are already named, or you say it's already defined. That's illegal. So remember, can't do that. Cannot do that. All right, C. What is C stating? C is stating that the order of the data types of the parameters in a function declaration must match the order of the parameters listed in the function definition. Okay, so we got to remember what the difference between function declaration is and what function definition is. So if you remember, function declaration occurs at the top of the program. So this is going to look something like this. Occurs above main, and if we have a function called foo, we have to declare what the data types of the parameters being passed into foo are. So we're passing in an int and a double, say, and then there's a semicolon at the end of this. And then the function definition is the function definition is actually where the function is actually defined down below main. So if we were to say do double x and int y, you'll notice that, so we'll have the body in there, but you'll notice that the first parameter was defined as an int up here, but now we're saying it's a double. Well, that doesn't make sense. That's probably not going to work. And this is a double, and now it's an int. That's not allowed. So this is not allowed. You can't do that, which means that this is true. The order of the parameters in the declaration also must match the order of the parameters in the function definition. So this is true. And notice that we don't necessarily in the declaration have to have the name of these parameters. We just have to have the data types. So this is saying the data types. It is not referring to the names. So we know that C is indeed the correct answer. Moving on to the next one. All right, this question is asking us which of the following statements regarding the scope of a variable is false. False. Keyword there, false. All right, statement A says that two variables must use the same identifier as long as their scope, or not must, may use the same identifier as long as their scope does not overlap in a program. And this is true. You could use, for example, if you in main had a variable named x, and then in foo, in the function foo, you also had a variable named x. This is allowed as these functions are in different scopes and aren't linked together whatsoever. There's a few examples of this earlier in the code, like some of the first few code questions I remember. I think questions maybe 1 and 2. Don't quote me on that one, but have examples of this where the names, the identifiers of the variables are the same, but the scope does not overlap because they're in different functions. So this is allowed. So this means that this is actually true. All right, B. A variable declared in the local declaration section of a function has a scope that extends until the end of the program. All right, well, so we know that this is actually false. False. And why is this false? This is false because the variable declared in the local declaration section of a function, so it's only defined in this function. The scope, therefore, only extends to the end of the function. It does not extend throughout the rest of the program, as that defeats the purpose of the scope of a function. So it only extends to the end of the scope of that function. It does not extend to the end of the program and to any other functions that it might encounter. And then C, just to cover our basis, it states that the scope of a variable or function determines the region of the program in which it is defined. And like we've kind of mentioned throughout, this is indeed true, as it is when you define a variable, it is only defined in that current scope or the current region of the program where it's defined. So if it's defined in a function, then the scope is determined by where it was defined, so the scope only extends into that function. So we know that B is our correct answer here. All right, question 23, almost there to the end. Question 23 asks us which of the following statements regarding structure charts is true. Structure charts, what in the world? Okay, which one is true? So the first one states that no code is contained in a structure chart and only demonstrates the function flow through the program. And this is kind of the whole idea of structure charts, is that you're not supposed to have code in them, because structure charts are supposed to just represent the flow of a program. So already we know that this is true, as structure charts shouldn't have code in them. So we'll just cover our basis here, look at the rest. And then it says, so B says each rectangle on a structure chart represents the user-defined and standard library functions used in a program. This is false. I don't actually, when I'm recording this, I don't have the materials available with me, so I can't remember exactly what a rectangle represents. I'm pretty sure it's something being executed or calculated or some sort of process. But I do know that it is not user-defined or standard library functions. Be sure to look in your textbook or in your course notes what the rectangle actually is, but do know that that is false. Sorry I don't have the answer readily available for that one. And then C, a structure chart will not display the data that is exchanged between functions. This is also going to be false, as this is not what structure charts are intended to do, because we're not supposed to be showing code or anything like that. I'm sorry, I misspoke there. This is false. This is false, as we do want to show the data exchange in a flow chart, as that is a very important part of the structure charts. As you know, it's hard to plan out a program if we don't know what's flowing between functions. So that is false. But A was very obviously true. So we know that A is incorrect. In fact, the correct answer. All right, moving on to question 24. Question 24 states that asks us which of the following statements regarding parameter passing is false. Keyword there, false. Which one is going to be false? So question A states that the called function must declare a special type of variable known as a pointer to store a memory address that is sent from the calling function. So when we say parameter passing, this usually I think means passing by address. So when we do use pass by address, we have to use a pointers, because we have to use a pointer to point to the memory address for pass by address. So that's kind of the whole idea behind pass by address. So we do know that this is, wrong color. We do know that this is actually going to be true. So B, the asterisk, which is this fun little symbol, has two different uses: declaring a pointer variable and indirectly is accessing the data. And so this is true. This is true. So what does this mean? So declaring a pointer variable is going to be something like int star x equals, it's going to be some sort of address, maybe the address of y, for example. And then indirectly accessing the data means that we're doing something like star x plus 2, maybe say y equals this. So as we see here, we use the asterisk for both of these instances, and therefore that's going to be true. So then we move on to C. C says the address operator, which is that ampersand there, when used in a function declaration, indicates that the parameter will not be a data variable, but rather it will be a pointer variable. And this is false. So a function declaration is going to be something like that occurs at the top of the program, like int foo, and then we have to say the data types. And when we say the data types, we use the asterisk actually, not the ampersand. So we do something like this. So we have to use ampersands, and this represents a pointer of int, so an address of int. We are not going to be doing something like int foo int ampersand and then double. That's not how you spell double. Double ampersand. That is not an ampersand. Whoops. Double ampersand. Sorry, those ampersands are not very good. But this bottom one here, this is not the correct way to do it. This is not the correct way to do it. This is the correct way to do it. So we know that this is actually going to be false, as the address operator is not used to do that. So we know that C is our correct answer. All right, moving on to our last question of this exam. The last question asks us, which of the following statements regarding parameter passing is false? Which one is false? First one states, a function that passes at least one parameter by address must pass them all by address. Must. This is false, which means this is the right answer. Why is this false? Well, we could have a function that does not pass all of our parameters by address. We could have something like int foo. And then we could do just a normal parameter, double x, and then we could do int star y. So that's this second parameter gets passed by address, but the first one doesn't, and this is completely legal. In fact, this occurs earlier in the test. I don't remember exactly which problem, but one of the pass by address problems has something similar to this, where one parameter is getting passed by address and one is not getting passed by address. So we know that's false. But let's take a look at the other answers too, just to see what they're about. So B states that not every function that utilizes pass by address are necessarily void functions. And this is true. Although it's bad practice, you can still return a value in a pass by address function. For example, this one I just wrote up here is returning a value of int. But like I mentioned, I'm pretty sure this is against course standards, so you wouldn't want to actually do this in practice, but it is technically legal in the C language. And then C, one benefit of pass by address is that it allows multiple changes to be made in a function and to have those changes available in the calling function. And this is the whole purpose of using pass by address, so this is true. As the primary purpose is exactly this. We want to change more than one thing in the main function, and so in order to do this, or not even just the main function, but whatever function's calling it, basically it's kind of like returning multiple values, and so we want to be able to change just more than one thing, so that's why we use pass by address. And so we know that A is our correct answer for this final question of this exam. And just like that, we are all done with the fall 2020 exam 1 for CS 159. If you have any questions or anything you found that was incorrect throughout the exam, please let me know in the comments of this video. Otherwise, thanks for watching, and hopefully this helped.